All right, so step 1, let's let u be 2x plus 1. Then du will equal 2 dx. Notice there is no 2 out front in our original integral, so we would take 1/2 du to equal dx. Go back to your integral and set it up in terms of u. This becomes, you have 1/2 up out front, 1 over u du. Now we can apply the definition of the natural log. The integral of 1 over u du will give you the natural log of u times 1/2 plus c. Don't forget, you need absolute value bars around u. When you go back and plug your original function in, you're going to be left with 1/2 the natural log of 2x plus 1 plus c. And I'm just going to write those as absolute value bars, no parentheses. Notice, just if you choose not to use u substitution, when you take the derivative of this inside, you're going to be left with 2. So in order to undo that, we stick the 1/2 out front. So if you want to skip the u substitution for a problem like this, that's okay if you understand how to undo some of the derivative. Okay. Careful with some problems when you have functions in your denominators. Here, we would let u equal 2x plus 5. Du would also give us 2 dx. And there's no 2 out front, so 1/2 du is equal to dx. If we were to start this problem, I'm not going to do the whole thing, we would rewrite it as 1 over u to the 1/2. Notice, the power is not 1. Natural logs don't apply here. You would do this regularly by rewriting it as, and I should have a du there, u to the negative 1/2 du, and go from there. This is not natural log. The exponent was not 1. Okay. Here is another example. If you want to pause the video and try it on your own at this point, you may, or you can follow along still. So in this case, we would let u equal x squared plus 2x. Du would give us 2x plus 2 dx. Notice we want x plus 1. In order to get that x plus 1, we would take half of both sides. So if you took 1/2 of both sides, you're left with 1/2 du equals x plus 1 dx. And that's exactly what we wanted. Rewrite your integral. I did not leave enough space. You need the 1/2 out at front, 1 over u du. I'm going to draw down here. When we take the integral, we get 1/2 the natural log of u, absolute value bars, plus c. Plug your function back in. 1/2 the natural log of x squared plus 2x plus c. And that is your final answer. Some of these get a little tricky with the algebra, so let's look at something like this. You have a polynomial and a binomial on the bottom. Usually what that refers to is some sort of long division. We know that if we were to plot the point 17 over 4 on a coordinate or a number line, the easiest way to do that problem would be to divide and have a remainder. So 17 divided by 4 would be 4 with a remainder of 1/4. Now that's easier to plot than 17 over 4. Same idea goes for integrals. Divide when you can. So recall that dividing, the easiest method when your coefficient over here is 1, is going to be synthetic division. So to set this up, we have negative 2, it's the opposite of this value. The leading coefficient of your polynomial, so 1, 4, negative 6, and negative 1. Set your bar up and begin. Bring down the first value, you get 1. Negative 2 times 1 gives us negative 2. Add vertically, 4 minus 2 gives us 2. Negative 2 times 2 is negative 4. Add again, you get negative 10. Negative 2 times negative 10 is positive 20. 20 minus 1, should that be a negative 1? Oh, no, actually the original problem, I'm going to make it a plus 1. You'll get 21. When I rewrite this polynomial, it's going to be a much easier integral to solve. I'll write it up here. This would give us the polynomial using these leading coefficients. Sorry, just up to there. And that's your remainder. So this would be x squared plus 2x minus 10 plus the remainder 21 divided by x plus 2. This is so much easier to integrate than the original. When you integrate this, you will get x cubed over 3 plus x squared after you simplify minus 10x plus 21 times the natural log, I'm going to fit this, of x plus 2. And plus c. I will rewrite that for you on the bottom of this screen. You should have x cubed divided by 3 plus x squared minus 10x plus 21, the natural log of the absolute value of x plus 2, plus c. Nothing to simplify there. Oh, this is gonna work. Okay. Now we're looking at taking the integral of e raised to a power, usually a variable or a function. So just to recall that when your function equals e to the u, your derivative, y prime, will equal the same exact e to the u times the derivative of your exponent, du dx. When you integrate e to the u, you will get e to the u, same thing, plus c. Only difference in the next problem we're going to do, you're going to have more going on in your exponent and you will need u substitution. Here's an example. You are going to have to let u equal the exponent for x. Then du will give you 4 dx. Since there's no 4 in your original integral, we will take 1/4 du equals dx. Again, you may skip this if you see it automatically. When I rewrite the integral, it is 1/4 the integral of e to the u du. We know how to integrate e to the u. That will give you e to the u itself. And don't forget the plus c. Plug back in what u equals, and you are done. Pause the video and try that again. Okay. U will be the exponent, and du equals 7 dx. Meaning 1/7 du equals dx. Rewrite your integral in terms of u and integrate. You will get 1/7 e to the u plus c. Plug your original function back in. And that's your final answer. Last one, possibly. Yeah. A little more going on in the exponent, but it is not bad. U will be the exponent 10x squared, meaning du will be 20x dx. I see the x right here. I don't see a 20. So 1 over 20 du is equal to x dx. When you rewrite your integral, you will have the integral with 1 over 20 out front times e to the power of u du. And that will give you 1 over 20 e to the u plus c. Plug your original function back in, and that will be your final answer again. Not bad. This one's a little easier than the last. The last one was just a little tedious, but still not difficult to do. Show your steps up until you can do this automatically without the u substitution. Once you understand it conceptually and procedurally, you can stop showing the u sub. All right. Peace out.